Hello class, this is a video tutorial on differential equations part 4. In this video, we'll be looking at separable differential equations. Since we now consider dy and dx as a variable, the main goal in differential equations is factoring all y terms with dy and all x terms with dx. Then we solve as we normally would. We've actually already seen this in the previous examples, but now we're going to be looking at far more complex differential equations. So these two examples shown here, these are the general cases that we're going to be looking at. So if we have a function of x divided by a function of y, we can actually multiply g of y with dy. So we've separated gy with dy. So the functions of y with the dy. We multiply by dx. And on the right hand side, we get f of x dx. And then from here, we would integrate as per usual. As for this, we can divide by gy. So we get 1 on g of y dy equals f of x dx. So this is generally what it would look like. Now it looks kind of odd when it is in f of x and g of y notation, because functions, well, the differential equations that we're going to be working with look more like this. So we're going to be looking at 6 examples in multiple videos. You can pause and give it a go at any time. In this video, we'll try and get to the first 2. Okay, so let's get straight into it. Now, I'm going to go a little bit more in depth with the notation here. Notice how the first, move it aside, this first one actually looks something like this. Now remember, our goal is to separate the functions of y with dy and the functions of x with dx. So y prime is just a notation for dy and dx. So we can use that instead. We cross multiply, I guess. We get 5y. Actually, no, we can leave it as y cubed dy equals 2 on 5 2/5 x dx. You could have also brought the 5 along with it, like so. So 5y cubed. You would still get the equivalent, I guess, relation in this case. But I'm going to integrate it like this. Notice how now this is similar to this. Okay, so let's now integrate both sides. So this becomes 1/4 y to the power of 4 equals 1/5 x squared. Multiply both sides by 4. It'll be 4/5 x squared, and we take the 4th root of both sides. And once again, we can place the plus c on the inside, like this, or plus c on the outside, like this. Oh, and I forgot the plus minus, because this is actually not a function, this is a relation. We'll see later that we can actually find the derivative of relations and not just functions anymore, but that's for later. So I hope you can see that it's still utilizing what we already know. It's just that now these integrations on the left hand side are getting a little bit more tricky. They are y to the power of 4. Okay, so let's move on to the next example. Let's crop this. I'll demonstrate to you how this is actually this one. Okay, so it may not look like it, but we can actually move things around. So it's x, y prime equals 2y. So we can move this entire thing to the right hand side. And now we can see that it's x dy dx equals 2y. And then from here, we can just manipulate. So we get 1 on 2y. Actually, no, I'm going to leave it as 1 on y. dy equals 1 on x, or 2 on x dx. So I've divided just by y to get 1 on y. And I've divided 2 by x to get 2 on x. And at the same time, I've multiplied by dx. We integrate both sides. We get ln of y, 2 ln of x. We take e of both sides. So this will give us e ln y equals e ln of x squared, which will give us y is equal to x squared plus c. And that is the solution to this differential equation. All right, so I hope that gave you an insight into separable differential equations. These are just much harder examples now. You can give these a go, and I'll see you in the next videos where we cover more of these examples. Hope to see you then, and best of luck.